On the Health Watch, a lot of people don't like getting their blood drawn, but it's often the only way to get some medical answers. Now, a first-of-its-kind device, only available here in Chicago, could ditch the needles and still get the same test results. Joining me now to talk about this, Professor Bozhi Tian with the University of Chicago. Professor, thank you for being with us. What an exciting development.
Thank you very much.
I'm sure this perked up the ears of a lot of people who do not like needles. So walk us through in layman's terms how this works and how accurate it is.
Yes, absolutely. So our device, we call it airborne biomarker localization engine, or you can just call it ABLE. So this device detects very tiny amounts of substances that are floating in the air. And this detection could indicate disease or environmental problems. So imagine you have a very diluted molecules in the air that regular sensors find hard to detect because they are too thinly spread. Now our device, our ABLE device, solves this problem by cooling the air to turn water vapor into droplets, like how dew forms on a cold window. So this process collects and also concentrates these airborne molecules into the water droplets, making them easier to detect with simple tests or sensors that are already available, such as the color changing strips. So the device used a special surface that is extremely water repellent. We call it a super hydrophobic surface. And this surface can allow the droplets to bounce and then collect effectively.
Fascinating.
And this will increase the sensitivity by thousands to millions of times compared to the regular gas sensors.
That's really incredible.
Thank you.
What was your inspiration for ABLE? I understand this was from a personal interaction.
Yeah, absolutely. So I would say there are both motivation and also inspiration. So my initial motivation of this work really comes from visiting a UChicago's neonatal intensive care unit right after the pandemic. And after seeing those preterm babies struggling, I start to ask myself, as a material scientist, can I actually design some gentle and non-contact sensors to monitor the health without adding stress or discomfort to the preterm infants? Now, turning to the nature's guidance or inspiration, I was really fascinated by how certain insects or plants, they can thrive under some very stringent environments. For example, some desert beetle, they actually survives by capturing some tiny droplets of moisture from fog, utilizing their very unique and highly water repellent surface. Now another example could be a lotus leaf. The lotus leaves remain clean and also dry despite this constant exposure to water. And this is because they're remarkable super hydrophobic textures. Now, inspired by those ingenious biological designs, we adopted the concept of the super hydrophobic surface to have this condensation system for sensors.
Professor Bozhi Tian with the University of Chicago and what could be the future of medicine. Professor, thank you so much for your work and your time today. Great talking to you.
Yeah, thank you very much.